Hi there, thanks for clicking on and watching. Going to give you some information about the OCR Maths A-Level exam and have a walkthrough of the 2021 paper 1. It's the November paper. If you are sitting OCR this summer, then there are 3 papers. There's the pure paper, pure and stats, and then the pure and mechanics. They are all worth 100 marks, all 2 hours long and all equally weighted and worth a third of the exam. Now each paper has a gradient of difficulty and consists of a mix of shorter and longer questions. For the pure and stats, there's 50 marks worth of pure and 50 marks worth of stats, and some of the questions will be set on the pre-release data set, which is on the OCR website. And then the same for mechanics, 50 marks on pure and 50 marks on mechanics. Now within these 3 papers there are these 3 strands. There's going to be some mathematical argument, and they're looking at your language and how you can prove things. There's some problem solving questions, and then there's some mathematical modeling questions. So all these 3 components are going to be assessed. There's some extended response questions and some stretch and challenge questions. The stretch and challenge questions are to support those pupils who want to gain A star at A level. The sets of assessments in any of the series will include at least one unstructured problem solving which addresses multiple areas of the problem solving cycle. So here's a list of command words from the OCR website. So if you're asked to give something in exact form, you might have to give it as a third, or maybe leave it as an ln. You shouldn't be giving a decimal if it says exact form. Hence means that whatever you've worked out in the previous part should be then used for the next part. If you're doing a show that question, don't start with what you're trying to show. That should be what you end up with when you have done all your working. You may use the results. They might give you some information that you're not normally expected to know, and you should use that result to answer the question. If you're asked to prove, you start with one side and end up the other. Verify, you're just going to substitute the values in. If you're doing a plot, it's going to be accurate as opposed to a sketch, which just shows the main features. You might have to draw a diagram and make sensible judgments about it. Give, state and write down. That's neither working or justification is required. You can just write them down. Find, solve or calculate. You don't need to give any justification. You can just write the answers down. Show detailed reasoning. Well, yeah, you are going to have to explain and show all your workings. If you're asked to determine, justification should be given for any result found. Include working where appropriate. Okay, let's have a look at some questions from OCR then. This is the November 21 paper 1. And yet they do ease you into the exam. They start with some shorter questions that are relatively easier. The harder ones are at the end of the paper. You couldn't predict what the questions are going to be on, but just know when you turn that paper, you should find that the start of the exam is relatively easier than the end. So what have we got for question 1 here? For 4 marks, find a set of values for k such that this quadratic has 2 distinct real roots. There are 3 cases where we can have different types of roots. When we have 2 real roots, we're going to be thinking about the discriminant, because that part of the quadratic formula, when we put it under the root and do plus or minus, we want it to give us 2 answers, and that's going to happen when b squared minus 4ac is greater than 0. So here b is 4, so b squared is going to be 16 minus 4, a is 1 and c is all of that k plus 3, so that has to be greater than 0. Multiplying out that bracket, 16 minus 4k minus 12 has to be greater than 0. 4 minus 4k has to be greater than 0, so 4 has to be bigger than 4k. So k has to be less than 1. Just be careful when you turn that inequality round and you make sure that the teeth point to the smaller end. So as long as we've got k less than 1, we're going to have 2 distinct real roots. This next question is the sort of question that you have to read a couple of times to just get your head around what's going on. We've got Alex comparing the cost of some mobile phones. Contract A has a setup of £40 and then you get charged 40p per minute. Contract B has no setup charge. You do not get charged for the first 100 minutes, but thereafter it's 6 pence per minute. And we have to find an expression for the cost of the contracts in terms of M, where M is the number of minutes for which the phone is used, and M is bigger than 100. So for contract A, we have got a setup cost of 40. Now that's in pounds, but then this is in 6p per minute. So let's put the £40 in pence. That will be 4,000 pence plus 4m. So every minute you have, it's 4 pence. Then contract B, because we get the first 100 free, we'd have to do m minus 100. So then we just get charged for what we have after 100, and that's going to be times 6p per minute for B. So that is our expressions for A and B. For part B, we need to find the M for which both would be the same. So we're going to say 4,000 plus 4M will have to equal the contract B, so which is 6M minus 600. Now, if we just collect all the m's on one side, you're going to get 2m, take the 600 over, that's 4,600, and divide by 2 is going to be 2,300. So at 2,300 minutes, both contracts would be the same. And if you want to put that back into either A or B, you'll get an answer that is in pence, but if you divide by 100, it comes to £132. This next question is a proportional question. So you do proportionality at GCSE, usually have the x is just proportional to one variable. Here we've got it being proportional to two variables and it's the product, but it's the same idea. X is proportional to the square of y and the square root of z. So we can replace the proportionality sign with x equals k, the constant of proportionality. And then we can use the information that when x is 30, we get that k times 2 squared times the square root of 9. So 2 squared is 4, square root of 9 is 3, so that's going to be 30 is equal to 12k. So 30 over 12 is equal to k. 12 goes into 30 2.5 times. So the connecting formula between these variables is that x is equal to 2.5 y squared square root of z. So then in part B, find the value of x when we've got y being 3, so that's 3 squared times the square root of 25. You put that in your calculator, it comes out to be 112.5. Question 4 is a factor theorem question. Now, just to go over the factor theorem, if I had a quadratic, so not this question, just a quadratic first, maybe x squared minus x plus 6, that factorizes to x minus 3, x minus 2. Now, when you have y equals to that quadratic and equal to 0, you're on the x-axis where y is equal to 0, and letting the factorized form equal to 0, we get a solution that x is equal to 3. So what value makes that bracket 0 when x is the opposite, if you like? X is going to be 3 or x is equal to 2. So in factorized form, the value that is the solution when it goes back into the multiplied out polynomial, then that will make this equal 0. So that is what you're looking for. In part A, it says that 2x minus 1 is a factor. We can see we've got a cubic. So we would have three brackets. We would have 2x in one of them, and it's telling us that 2x minus 1 is the factor with the 2x. The other two brackets would have to have x and x in order to get that 2x cubed. And then we can already think about this plus 6. It's going to have to be maybe 6 and 1 or a 3 and a 2 in order to get that 6 on the end. But part A says use the factor theorem to show that the 2x minus 1 is a factor. Well, if 2x minus 1 is a factor, then if we solve that equal to 0, and then the x that would make that happen in that first bracket is x going to be equal to a half. If we do f of a half and get 0, that shows that the 2x minus 1 was a factor. So what is f of a half? We have to put a half back into our cubic, so it's 2 times a half cubed, which is an eighth, minus 3 times a half squared, which is a quarter, minus 11 times a half, and then plus 6. The 2/8 here is a quarter. Minus 3/4 is going to be minus a half, minus 1 half minus another 11 halves is minus 12 halves, and which is minus 6 plus 6 equals to 0. So that shows that at the 2x minus 1 is a factor. So that is part A. Part B, express in a fully factorized form. Well, you can go on and carry on seeing if you can guess. Because we've got a minus here, we're going to have a plus and a minus in these, and you can try f of 3, f of minus 2, or f of minus 3 and f of 2, and carry on seeing to see what these brackets could be, or you could do your long division. So pupils kind of like long division. I maybe wouldn't do it, but let's have a little go here. 2x cubed minus 3x squared minus 11x plus 6. So 2x into 2x cubed, so you take the first term and divide it into the first term there. That would give you x squared. As soon as you get an answer on the top, you times it by everything on the front and right underneath to get your remainder. So that would be 2x cubed minus an x squared. The first two terms are always going to cancel because you've just divided and then times back up. So then the second term minus 3x squared minus will be minus 2x squared, and then bring down the minus 11x, the plus 6, and now go again. 2x into minus 2x squared is going to be minus x. An answer on the top needs to times by everything on the front. You're going to get the minus 2x squared and then plus x. Minus 11x minus another x is minus 12x plus 6. Then you go again, 2x into that is going to give you minus 6. Answer on top times by everything on the front. You're going to get minus 12x and then plus 6, and we get our 0. So here we have got, it's what that I had up here, x squared minus x minus 6, and in factorized form, it's not quite what I had up there, I had a minus 6. It's going to be x minus 3 and plus 2 to give us that minus in the middle. So that is our fully factorized form. 2x minus 1, x plus 2, and then x minus 3. Now having a look at part C, and because it says hence solve, that means you can use what you've already found out to help you to do this part of the question. So notice we've got 2 times something cubed, and we've got 2 times something minus 3 times something squared. We've got a minus 3, a minus 11, and a plus 6. So it kind of looks similar. What you've got to spot is the 8 and the 4 and the 2. 8 and 4 are both powers of 2, so we can write this as 2 times 2 cubed to the y minus 3 times 2 squared to the y minus 11 times 2 to the y plus 6 is equal to 0. Now what we can do when you times these together, when you're timesing, order doesn't matter. So we can write this as 2 times 2 to the y all cubed minus 3 times 2 to the y all squared minus 11, 2 to the y plus 6. And then we can let x equal 2 to the y. So then we'll have exactly what we've just had before, 2x cubed minus 3x squared minus 11x plus 6. And what was that in factorized form? It was 2x minus 1, x minus 3, and x plus 2. So in factorized form in terms of x, but we've used this substitution in order to get the solution, to get the factorized form. So here x would equal a half, x would equal 3, or x would equal minus 2. But what was x? X was 2 to the y, so 2 to the y can equal a half, 2 to the y can equal 3, or 2 to the y can equal minus 2. So 2 to the y is 1/2. Well, 1/2 is 2 to the minus 1. So 2 to the y equals 2 to the minus 1. Y is equal to minus 1. Now, we can't think of anything 2 to the y which will give us 3. But if we take logs, log to base 2 of 3 is equal to y would be our solution for that one. Now, 2 to the y equals minus 2. If you think of the 2 to the something graph, that is not going to go negative below, so that's a no solution. So there are answers that y is equal to minus 1 or y is equal to log to base 2 of 3. It doesn't ask us to give it in exact form, so you could put that one as a decimal if you wanted, but I think that would get you the marks. Log to base 2 of 3 is equal to y. This next question is a transformation of graph question for part A, and then we've got the graph of a gradient function for part B. So A and B are not related. In part A, it's telling us we've got a function f of x with the coordinate 2, 6 on it. State the coordinates of the point P when we have the following transformations. So for part 1, just an add 3 on the outside. That is going to be plot the graph, and then just before you plot 2, 6, we're going to add 3 to the y coordinate. So that's going to be a translation of 0, 3. So the coordinate will go to 2, 9, just adding 3 to that y coordinate. In part 2, we've got 3 transformations. We've got 2 on the inside, which are going to affect the x coordinate, and 1 on the outside, which affects the y. So the easy one on the outside is just 2f of x. So that is just going to double the y coordinate. So the y coordinate is going to go to 12. Now, thinking about the x coordinate, you will always have to think, and it works the opposite way to what you think when you're changing the x coordinate, and also the order has to go in the opposite way, because you have to think what y answer would you get when you put that x value in. So here on the inside, we've got a times by 3 and a minus 1. Well, the minus 1 is going to send it 1 to the right, and the timesing by 3 is going to be the x coordinate divided by 3. But which order do we apply them? You apply them when it's the transformation on the inside in the opposite order from BIDMAS. So we need to take 1 away first, and that would be sending it 1 to the right. So the 2 would go to 3, and then we need to divide it by 3. So then that would go to 1. Now in part 3, we're being asked to do the inverse. So we've got our point, which is at 2, 6, and points of the inverse function are a reflection in the line y equals x. So we want to know, where does that point go to in the reflection y equals x? It would go over here, which would be 6, 2. So that's how to think about where points go when you have their inverse. Now in part B, we've got this graph here, g dash of x, which is the gradient function of some curve y equals g of x. The graph intersects at -2 and 4. And here we've got to just state what we think is going to happen in these situations. So state the x coordinate of any stationary points. Well, because this is the gradient function, when the gradient is 0, that's telling us we've got a stationary point. So the x coordinate at the stationary point will be x equal to -2 or x is equal to 4. In part 2, state the set of values for which y equals g of x is decreasing. It's decreasing when the gradient is negative, and that's this section here of the graph where we can see the section is below the y-axis, which would give us a negative value. So it's going to be that x is less than -2 would be a decreasing function. Part 3, state the x coordinates of the point of inflection. So here, when we've got a stationary point at -2, we can see before that -2 the gradient was negative because it's below, and then after the -2 the gradient is now above, so that's positive. So when the gradient goes from negative to positive, that's telling me that I've got a min. But here for the 4, I can see the gradient is above 0 before the 4, and then it is still above 0. If we think of the x-axis as our 0, all of this section here, the gradient is positive. So the point of inflection is going to be at x equals 4 because the gradient either side of that turning point has stayed the same. They're both positive. This next question is a binomial expansion. You get on the formula sheet that 1 plus ax to the n is equal to 1 plus nax plus n into n minus 1 over 2 factorial ax squared. Plus obviously dot dot dot, but we just want the first 3 terms, so they're all the terms we will want. So for part A, you can't do binomial expansion with a fraction or a negative in the power unless you've got a 1 in this position, so we have to take 8 out as a common factor, then it'll be 1 minus 3 over 8x, and that will be all to the third, and then we can take that third into everything in that bracket. So 8 to the third is going to give us 2 times the 1 minus 3 over 8 to the third. And then we're going to use the binomial expansion formula to expand that. So it's going to be 2 times 1 plus n, which is 1/3 ax, which is minus 3/8 x, plus a third, which is n, and then n minus 1, which is a third, minus 3/3, which will be minus 2/3, all over 2 factorial minus 3 over 8x all squared. And then if we tidy that up, it's going to be 2 into 1 plus these 3's will cancel. The minus will make that minus in the middle, so that will be x over 8. And then here, the 3 squared will be 9, which will cancel with these 2 3's. We've got this 2 will cancel with this 2. The minus here squared will be a plus, so we'll have 64 on the bottom with this 8, and that will be plus 64, but then minus here, so it'll be minus x squared over 64, and then take the 2 in, that's going to be 2 minus x over 4 minus x squared over 32. For part B, state the range of values for which it is valid. Well, you always just take this part here and say that that is going to be between minus 1 and 1. So that's 3/8 of x. And then we just rearrange, cross multiply to get x on its own. So that minus 8/3, x will have to be greater than that or smaller than 8/3. Part C, find the coefficient of the x squared term in this. So we've just expanded that top. Now we need to think about the bottom. 1 plus 2x to the minus 2, we've brought it in the numerator position. And then using the same expanded formula that we get on the formula sheet, we can say that's 1 plus nax, which is minus 2 times 2x, plus n minus 2 n minus 1 all over 2 factorial 2x all squared. Now we only need up to the x squared term, so let's tidy that up. It's 1 minus 4x. This 2 will cancel here. The minus times the minus here will make a plus. 2 squared is 4 times 3 is going to be plus 12x squared. So now putting these both together, we've got 2 minus x over 4 minus x squared over 32 plus dot dot dot. That's the numerator times this denominator, which we've just brought in the numerator and expanded. And then we just need to think about which terms will give us coefficients of x squared. Well, it's going to be when the 2 times is by the 12, when the x over 4 times is by the 4x, and when the x squared over 32 times is by the 1. So all together, the x squared coefficient is going to be 2 times 24. And then this minus a quarter times minus 4 will give us a plus 1. And then we're going to have a minus 1 over 32. So not 2 times 24, 2 times 12, which is 24. So that's 24 plus 1 is 25. Minus 1 over 32 is 24, and 31 over 32, which is the same as 799 over 32. Next, we've got a numerical methods question, and we've got this equation here, y is equal to x squared minus 2 into ln of x, stationary close to x equals 1. Show that the x coordinate of the stationary point satisfies this equation. So when we're looking for stationary points, we're going to be finding dy by dx and equating that to 0. Now, if we look at the equation, we can see it's two terms multiplied together that both contain the variable x, and we're going to be using the product rule. So that is the first, which is x squared minus 2. So x squared minus 2 times the differential of second, which is ln of x. Ln of x differentiates to 1 over x, plus the second ln of x differential of the first, which is 2x. Just going to put that in front so it doesn't get mixed up with that x there. And if we're looking for stationary points, then all that equals to 0. Now, to get what we're after, all we need to do is go clear of these fractions, clear of this denominator, and multiply throughout by x, and that will give us x squared minus 2 plus 2x squared multiplying by x. Ln of x, it's still equal to 0, and then all we need to do is rewrite it in the way they've got it. They've got the 2x squared ln of x term first, plus x squared minus 2 is equal to 0, and that's part A. Part B is asking us to show that the Newton Raphson iterative formula for finding a root for the equation we've just got, which is this equation here from part A, can be written in this form here. Now, the Newton Raphson formula is that the next one along is equal to xn minus f of xn all over f dash of xn. So we need to differentiate. And the f of x is going to be this equation here, this function here. So I'm going to just do all of this just with x's and put the xn's in at the end maybe. So we're going to have the x minus the f of x, which is our equation, 2x squared ln of x plus x squared minus 2 all over f dash of that equation that we've just written down. So we can see again we have got a product, so that's going to be first differential of second, which again is 1 over x, put that on the bottom, plus second differential of first, which is now going to be 4x, and then moving along the other terms differentiate to plus 2x, and then the 2 will go out. Now we can see this x will cancel here, so we've just got 2x here plus another 2x. So we've actually got 4x on the bottom and then another 4x plus ln of x there. Now it wants it as a single fraction, and at the moment it's two terms. So what we can do is give this the common denominator that we've got on the bottom. So if we say x times the 4x plus 4x ln of x minus, and then all of this will need some brackets around it because it's minus all of those terms, and there's three terms there. So it's 2x squared ln of x plus x squared minus 2. And then that can all go over that common denominator, 4x plus 4x ln of x. Now all we need to do is collect like terms. We can see here, multiplying that x in, you're going to get 4x squared, and you've got minus an x squared here. So we're going to get 3x squared, and then multiplying those two together, you're going to get 4x squared ln of x, and here you've got minus 2x squared ln of x. So that will be plus 2x squared ln of x, and then you'll still have a minus 2, so that will be plus 2 all over. Now what I can do here to get what they want, they've taken a factor of 4x out, and then they'll have just do it the other way around, it's ln of x plus 1. So writing it in the order they've got it, we can say that x of n plus 1, just putting the xn's in now, is our 2xn squared ln of xn plus our 3xn squared plus the 2 all over our 4xn ln of xn plus 1. So that's part B. Part C, I have to do here. Apply Newton Raphson with your initial value x1 is equal to 1. So on our calculators, if we just type in 1 and then equals, and it should put 1 in the bottom right hand part of the screen, and then type in all of this iterative formula, but wherever you see the xn, you're going to type in the answer key, which is down at the bottom, and then each iteration it will then feed in the previous answer. So if you do all that, then you get x2 to equal 1.25 and x3 to equal 1.2077. Now it just wants x2 and x3. But if you keep pressing your calculator, the root settles down to 1.206. Now in part D, it's asking us to find the coordinates of this stationary point. So we're going to use the root where it's settling down from our Newton Raphson, which is 1.206. And then to find the coordinate, what we need to do is put that 1.206 into this y equation, and that comes out to be minus 0.102, and that is the coordinate of the stationary point. Question 8 is a functions question. So we've got f of x and tan of x as two trig functions, and we're asked in part A to state the range of f. So f is double tan x. If you think about the range, so go up and down the y-axis, where does that graph exist? Well, the fact that we're doubling the tan is just going to still go up to infinity and down to infinity. So f of x, the values belong to the real, and it goes from minus infinity to infinity. State the range of g. So g is sec x, which is 1 over cos. So if we draw and think about the cos graph, then if I put in the 1 over that, so where we've got 1 over 1, it's going to go there, but when it goes here to 0, 1 over 0 is going to go to infinity, and then it comes down here, and then it comes down here. So that's the set graph in red, and it is above 1 and then below -1. So we can write that as minus infinity to 1 and 1 to infinity. So where you have this interval notation, the rounded bracket means it doesn't equal it, but the square bracket means that it can equal. So that is the interval notation. Right, in part B, show that fg of 0.6 is 5.33. So we need to put it into g first. So sec of 0.6 is 1 over cos of 0.6, which comes out to be 1.2116, and then we need to put that into f. So f of 1.2116 is 2 times tan of 1.2116, which on your calculator comes out to be 5.3269, which is 5.33 for part B. So we've shown, yeah, we've got it there to 3 significant figures. Part 2, explain why the inverse of f times g of x, so that would mean doing g of 0.6 first and then putting that into the inverse. We're looking at what f of x is because it's tan x. Tan x going from 0 to pi is a many to 1. So fx is many to 1. Now only 1-to-1 functions have inverses, so many to 1, so will not have an inverse, because if it did have an inverse, then you'd have 1 to many, and anything to many is not going to be a function. Right, part C, show that when we do f of x all squared plus 6 times g of x equal to 0, and solving that equation, so f of x is 2 tan x, so squaring that will be 4 tan squared x plus 6 sec x is equal to 0. Now using the identity that tan squared x plus 1 is equal to sec squared x, we can rewrite the 4 tan squared as 4 into sec squared x minus 1 plus 6 sec x, because the idea whenever you've got anything quadratic is to get it all in terms of one ratio. So multiplying that out, you've got 4 sec squared x plus 6 sec x minus 4 is equal to 0. Divide by 2, 2 sec squared x plus 3 sec x minus 2 is equal to 0. And then we can factorize it. We've got 2 sec x and sec x to get the 2. It's going to be a minus 1 and a plus 2, because then we'll get those two will give us 4 sec x, minus 1 will give us the 3 in the middle. And then if we say that sec x is equal to a half, or sec x is equal to minus 2. Now sec x equaling a half, remember when we just had the graph before, sec x can't equal a half, so that's no solution. Sec x has to be above 1 or below minus 1. And then the other one, sec x is equal to minus 2, will tell us that cos x will have to equal minus a half. So cos of 60 degrees, which is pi by 3, is a half. So cos of 120 is going to be minus a half. So x will equal 2 pi by 3, And then the other one will be pi plus pi by 3, which is 4 pi by 3. Question 9 is parametric equation. We've got x and y given in terms of this third variable t. For part A, explain why the path of the particle is never going to cross the x-axis. Well, if you think about when things are on the x-axis, then y is equal to 0. And if we look at the y equation for all t, y is going to be greater than 0 because y is governed by this exponential equation, and it would be a graph like this that would tend towards that axis but will never go through. So for all t, y is going to be greater than 0, therefore it will never cross the x-axis. For part B, determine the exact values of the path when it intersects the y-axis. So intersects the y-axis when x is equal to 0. Now x is this equation here, which is a disguised quadratic. We've got e to the t squared minus 4e to the t plus 3. So we can factorize that. It's going to be e to the t times e to the t. 3 and 1, two numbers times together to give you 3. It'll have to be minus and minus. So that's the x equation factorized. So when it equals 0, e to the t is going to equal 1, or e to the t is going to equal 3. So what value will make e to the t 1 when t is equal to 0, or when t is equal to the ln of 3. So we need to find the exact values of t. So we've done that. We don't need to put them back in to find the actual coordinates, just the values of t. Part C, show that dy by dx is this here. So because we've got the curve given parametrically, we'll have to do dy by dt. So differentiating the y equation, the minus 3 is going to come down. You're going to get minus 6e to the minus 3t. And then dx by dt. So differentiating each term, we're going to get 2e to the 2t minus 4e to the t, and then the 3 will go out. And now we need to make a chain. Dy by dx is going to be dy by dt times dt by dx. So informally, they aren't fractions, but they can behave where the dt's will cancel. So dy by dt is minus 6e to the minus 3t over, because we notice here that this is the dx by dt upside down, so we'll have to put this expression underneath. So that will be 2e to the 2t minus 4e to the t. Now that's not quite the format that they want. They've just got 3 on the top. So if we look at our numerator here, how are we going to get a 3 there? Well, what we need to do to all the terms, the top and both of them on the bottom, is we need to divide by minus 2e to the minus 3t. So can you see that will cause us to have a 3 in that numerator? So that's going to give us a 3 on the top, and then we'll have 2e to the 2t divided by minus 2e to the minus 3t minus 4e to the t divided by the minus 2e to the minus 3t, because you have to divide by this through all the terms. On the top it's given us the 3, but on the bottom you can see that these 2's are going to cancel, and then you're going to use your rules of indices to take these away. 2t minus minus 3t will give us 5t, so that will be minus e to the 5t, and then the next term, the 4 and the 2 will cancel and give us a plus 2, because this minus minus will give us a plus, and then here we'll have in the indices t minus minus 3, which will be 2e to the 4t. So just putting it in the format that they want, it's going to be 3 over 2e to the 4t minus e to the 5t. For part D, hence find the coordinates of the particle when its path is parallel to the y-axis, and it says hence, so that means we've got to use something we've just found above. And if we use this, if we think about the gradient when we're parallel to the y-axis, so here's the y-axis. When we're parallel, we have to have a gradient of infinity. It needs to be completely vertical. And that is going to happen when the denominator equals 0. So we have to let 2e to the 4t minus e to the 5t equal 0. So taking the minus e to the 5t the other side, 2e to the 4t will equal e to the 5t. Now divide by the e to the 4t. 2 is equal to e to the 5t over e to the 4t. Take away those indices and that will be e to the t. And then taking ln's on both sides, t will equal the ln of 2. Now it's after the coordinates, so we found when t is equal to ln of 2, that's going to happen, but we'll have to put it back into our x and y equations. So when t is equal to the ln of 2, x is going to equal e to the 2 ln of 2 minus 4 e to the ln of 2 plus 3. Now using your log laws, take that 2 up and it will be e to the ln of 4, so that will just be 4. The next one, e to the ln of 2, will just be 2, so that will be minus 8 plus 3. So x will be 4 plus 3 is 7, minus 8 is minus 1. And what will y be? Y will be 2 e to the minus 3 ln of 2, which will be 2 e to the, take that up, it will be the ln of 2 to the minus 3, which will be 2 times 2 to the minus 3, which is an eighth, which will be 2/8, which is a quarter. So the coordinate where it's parallel to the y-axis is minus 1 1/4. In question 10, we've got this triangle here. We've got the angles at the top, x and y, and we can see we've got two right angle triangles. The hypotenuse of these are A and B. In part 1, we're asked to explain why the length CD, which is the height of the triangle, how can that be written as A cos Y? Well, as soon as we've got right angle triangles, we can know that we're going to be using SOHCAHTOA. So I like to write them out with the middle bit in the air. Now, adjacent to that angle Y is the length that we're trying to find, and we know that cos Y is going to be the adjacent divided by the hypotenuse. So the adjacent is going to be the hypotenuse times the cos. The hypotenuse in that triangle is A, so we can say that CD is equal to A times cos Y. Now in part 2, it's asking us to show that the area of the triangle ADC, which is the triangle on the left, is equal to half AB sine x cos y. Well, we know that the area of a triangle is half AB sine C, where A and B are two sides and the angle C is the angle between them. So this is going to be half times A to C times C to D times sine of the angle between them, which is x. So half A to C is B, C to D is what we've just worked out, A cos y. And then we've got sine x, and then putting that all together, that's going to be half AB, and then putting it in the order, they've got sine x cos y. Now in part 3, it says hence or otherwise show that sine of x plus y, so that's the total angle there, is given by this expression. Now this is the sort of question, it says hence or otherwise, you've just done these two parts. What on earth have they got to do with this compound angle formulae? Well, we've just found that the area of this triangle here on the left is equal to this expression, and we use the fact that the CD and we got the a cos y from this triangle. Now if we do that all the other way round, so for part 3, if we get another expression for CD and work in the left hand triangle, so this is going to be adjacent to now angle X, and it's going to be equal to B cos of X. And then if we get the formula for the area of this triangle here, so the area of, what is it, BCD, that's going to be half times A times this thing here, B cos X, that would be the half of the two sides, and now times by the included angle, which is sine Y. And then if we find the total area of the triangle and add them both up, so that will be half. Now we're going to use the whole of this angle here, and the two sides either side of that included angle are going to be A and B, so that will be half AB sine of X plus Y, and equate that to the two things that we've just added up as separately, the two triangles either side. So that's going to be half AB sine X cos Y plus half AB sine Y cos X. And then all we need to do is cancel through by the half AB to find that sine of X plus Y is equal to our sine X cos Y plus cos X sine Y. In part B, we're going to use our addition formulae here to expand, which is a little bit of what we've been doing in part A. We've been proving it. You're not really going to use very much of what you've done in part A for part B, but in part B, you are given that the sine of this angle is equal to the cos of this angle. Now, you can't just move that down to get some tan because these angles are different. So we're going to have to expand them using our compound angle formulae. So sine 30 plus alpha is going to be sine 30 cos alpha plus cos 30 sine alpha. And it's telling us that that is equal to, and then expanding the cos one, that goes to cos 45 cos alpha. Now when it's minus in the middle for cos, it's going to be plus sine 45 sine alpha. Now using your special triangles, we know that sine 30 is a half, so by Pythagoras that is root 3, and we know that tan 45 is 1, so by Pythagoras that is root 2. So sine 30 is a half, so that will be half cos alpha. Cos 30 is root 3 over 2 sine alpha. Cos 45 is 1 over root 2 cos alpha, plus sine over 4, sine 45 is 1 over root 2 sine alpha. Now I'm going to collect all my sines to one side and all my cos to the other side. So I've got root 3 over 2 minus 1 over root 2 sine alpha, taking that one to the other side, is equal to 1 over root 2 minus a half cos alpha, taking that one to that side and taking the sine alpha and cos alphas out as a common factor. Then we can make these single fractions. So that's going to be root 3 times root 2 minus 2 all over 2 root 2. Sine alpha is equal to 2 minus root 2 all over 2 root 2 cos alpha. The 2 root 2's can cancel on both sides, and then we can have sine alpha over cos alpha is going to be 2 minus root 2 over 3 root 2, which we can write as root 6 minus 2. And now we've got sine over cos, which is tan alpha. And all we need to do is rationalize the denominator. So that would be root 6 plus 2 over root 6 plus 2. So on the bottom, you're going to get 6 minus 4, which will be 2. And then on the top, you're going to get 2 root 6 plus 4 minus root 12 minus 2 root 2. So that is going to be 2 root 6 plus 4, and then root 12. Underneath the root is 4 times 3. The 4 will come out as 2, so that's minus 2 root 3 minus 2 root 2 all over 2. And then all we need to do is cancel by 2 throughout, so that's going to be root 6 plus 2 minus root 3 and minus root 2, which is what they've got there. So that's equal to 2 plus root 6 minus root 3 minus root 2. Just 2 questions left, and this is the start of question 11, which is an integration by substitution. So we need to substitute for everything in the integral, the numerator, denominator, and the dx. I can see that u squared is equal to x squared plus 3, then u is going to equal the square root of x squared plus 3. So that's the denominator sorted. In order to get dx on the go, I need to differentiate. Now u in the substitution is not given explicitly, so I'm going to have to use implicit differentiation. So that is differentiating with respect to u, but because it wasn't x, we then have to write du by dx is equal to differentiating on the right 2x. So now I want to know what dx is worth, and because part of this numerator involves an x, what I can do is say that 2u du is worth 2x dx. So I've got the dx and I've got part of that numerator. So I've got 2x. In order to get 4x cubed, I need another 2x squared. And I can see that x squared is u squared minus 3, so 2 of them is going to be 2u squared minus 3. So now I'm ready to make the substitution. I'm going to have on the top a 2 into u squared minus 3 times the 2u du all over u. These u's can cancel. The 2 times the 2 is going to give me 4, and then I can times it into the bracket 4u squared minus 12 du. And now integrating 4u cubed over 3 minus 12u plus c. Now I have to substitute back. U was the square root of x squared plus 3, so that's x squared plus 3 to the half. So I've got 4/3, and then u is x squared plus 3 to the half, but I want it cubed, so I need a 3 on top, minus 12 of x squared plus 3 to the half. Now to get it in the way they want, I can see I've got a 4/3, and this bit here in the square root is my x squared plus 3 to the half. So if I take out 4/3 x squared plus 3 to the half, and then inside the brackets I'll need another x squared plus 3. And that will be to the 1, which when it times us by this will give me the 3 over 2. And then because I've got the x squared plus 3 to the half out as a common factor, I've also taken 4/3 out. So I need to divide the 12 by 4/3, which is the same as timesing it by 3/4. 3/4 of 12 is going to be minus 9. So when that 4/3 times back in, I would get the 12. So now this is going to be 4/3. This here, the plus 3 and the minus 9 is going to give me x squared minus 6, and then all times by this, which is x squared plus 3 to the half, which is the same as the square root. And don't forget, we've got our plus c. In part B, we have the graph of the curve we've just been working with, and we're asked to find the exact area enclosed by this curve, the normal to the curve at the point 1, 2, and the x-axis. So let's just check the point 1, 2. Is that on the curve? So when x is equal to 1, y is going to be 4 times 1 cubed, which is 4, over 1 plus 3 is 4. Square root of 4 is 2, which is 2. So our point 1, 2 lies on the curve. So if we integrate between 0 and 1 and find the area of here, it's then asking us for the area that's enclosed between the normal to the curve and the x-axis. So we need to add on this area here as well. So first of all, we'll do the integration. So we need to integrate between 0 and 1 of 4x cubed over our square root of x squared plus 3. And we know that that is this here, but we don't need the plus c because we're now doing definite integration. So that will be 4/3 x squared minus 6 times the square root of x squared plus 3 between 0 and 1. So putting 1 in, we're going to get 4/3 times minus 5 times the square root of 4, which is 2. Put 0 in, our lower limit, we're going to get 4/3 times minus 6 times the square root of 3. So we times this top, we've got minus 40 over 3, and then minus minus will make a plus, and we've got 24 over 3 root 3. So altogether this is minus 40 over 3 plus 8 root 3. So that's this section here under the curve. Now we need to find the equation of the normal and find this point here, because we're going to be using half base times height to add on this triangle. So in order to find the point here where it crosses the x-axis, we'll need to find the equation of this normal. So to find an equation of a normal, we have a point 1, 2, we just need the gradient. So we're going to have to find dy by dx. Now we've got a quotient, so the quotient rule you get on the formula sheet, but it is the bottom, which is x squared plus 3 to the half, differential of top, which is times 12x squared, minus the top 4x cubed, differential of the bottom. So we need to power down and use the chain rule. So take 1 off, and then times the differential of the inside will be 2x. All over the bottom squared, which will just be our x squared plus 3. Now we want the gradient when x is equal to 1. So when x equals to 1, dy by dx is equal to, when x is 1, 1 plus 3 is 4, square root of 4 is 2, times 12, minus, now here this 2 and this 2 can cancel. We've got in here x squared plus 3. When x is 1, that's going to be 4. Square root of 4 is 2, and 1 over that will be a half, and that will times by this half and get us 2, and it'll be all over 1 plus 3 is 4. So that's going to be 2 times 12, 24, minus 2, 22 over 4, which is 11 over 2. So the m of the normal will be minus 2 over 11. So we want the equation of the normal will be y minus 2 is equal to minus 2 11ths x minus 1. Now multiply by 11. 11y minus 22 is minus 2x plus 2. Take everything to one side. We've got 2x plus 11y. Put the numbers on the other side will be equal to 24. Now we're interested in the place where y is equal to 0, so we can kind of cover that part up. What will x be? X will be 12. So the area of the triangle will be half times its base, which we can see is going to be 11, times its height, which is 2. They'll cancel, so the area of that triangle is 11. So the total area will be our 8 root 3 minus 40 over 3, and then add on the 11, which comes to 8 root 3 minus 7 over 3. On the last question now, so we've got a cake cooling, so that 2 minutes after it's removed from the oven, its temperature is theta. When the cake is removed, so when T is equal to 0, the temperature is 160. After 10 minutes, it's cooled down to 125. In this model, the rate of decrease of the cake is going to be constant. Write down a differential equation for this model. So if we're told to write down something we should just be able to write, a differential equation contains dx by dy, or in this case it's going to be d theta by dt. Whenever we've got the word rate, it's going to be a differential equation with respect to time. Now we're told that's a constant, and the letter you usually use to represent a constant is going to be k, and we're saying that it's decreasing, so it's going to be minus k. Now, part 2, we're asked to solve that differential equation. So how do we solve differential equations? We separate the variables and integrate. So you're going to have d theta is equal to minus k dt. And then integrating, we're going to get theta is equal to minus kt plus c. Now we've got two constants to find, the minus k and the c. We find the c from the initial information, which at t equals 0 is 160. So we know that 160 is equal to, if t is 0, the minus kt will be 0 plus c. So that tells us that c is equal to 160. And then after 10 minutes, so that's when t is equal to 10, the temperature is now 125. So 125 is equal to minus 10k plus, now we know what c is, 160. Just rearranging that, we're going to get that 160 minus the 125 is equal to 10k. 10k is equal to 35, so k is equal to 3.5. So our equation for this initial model is that theta is equal to minus 3.5 t plus 160. Now part 2, state one limitation. The limitation is that the model predicts that it will decrease forever. So it's going to decrease past the room temperature and past even freezing. So that's not going to happen. The temperature of the cake is going to cool down to the temperature of the room and then remain at that temperature. In part B, we've still got the same situation. The cake is cooling, and when it comes out of the oven, T equals 0 and it's 160. 10 minutes later, it's fallen to 125. Now they have revised the model to say that the rate of decrease is proportional to the difference between the temperature of the cake, which is theta, and the temperature of the room. And we're told that this is constant at 20 degrees. So for part 1, we need to write down the differential equation. So again, that's going to contain d theta by dt. Now it's equal to minus k, that's our constant of proportionality. And now, because we're told it's the difference between the temperature of the cake, which is theta, and the temperature of the room, so we just need to do a takeaway. So that's what they'll be looking for 1 mark for part 1. Part 2, we're now being asked to solve this. So how do we solve a differential equation? We separate the variables and integrate. So this theta minus 20 needs to cross multiply and come down. So it's going to be 1 over the theta minus 20 d theta, and then take the dt up. So it'll be minus k dt. Now we have to actually integrate, so that will be the ln of theta minus 20 is equal to minus kt plus c. Now again, we need to use our information, so when t is equal to 0, theta is equal to 160. So when t is equal to 0, theta is 160. So feeding those in, we're going to have the ln of 160 minus 20, 140 is equal to, well, as t is 0, you're going to have 0 plus c. So that tells us c is the ln of 140. And then the other bit of information to find k, when t is equal to 10, theta is 125. So the ln of 125 minus 20 will be 105 is equal to minus 10k plus, now we know what c is, ln of 140. If we take the 10k to the other side, we're going to have 10k is equal to the ln of 140. Using our log laws, the ln of 105 on the other side will be minus, and then we can represent that as a divide using our log laws. So k is equal to 0.1. The ln of 140 over 105 is 4/3. So putting that all back in, we're going to get the ln of theta minus 20 is equal to our minus k minus 0.1, the ln of 4/3 t plus the ln of 140. Now because we've got a minus here, we can use our log laws and take that up and raise 4/3 to the minus, which will swap the 4/3 round. So we're going to have the ln of theta minus 20 is equal to 0.1, the ln of 4/3 upside down is 3/4, so 0.75 t plus our ln of 140. Now we're asked to solve this equation to find theta in terms of t. So that means we need to have theta as the subject, and at the moment it's inside this ln. So if we raise to the power e on both sides, we're going to get that theta minus 20 will equal e to the 0.1 ln of 0.75 t plus the ln of 140. Now when we've got this plus here, this can be written as e to the 0.1 ln of 0.75 t times e to the ln of 140. Now they can cancel with each other, and we can just put that 140 on the front. So theta minus 20 is 140 e to the 0.1 ln of 0.75 t. Now we just make theta as the subject. Theta is equal to 140 e to the 0.1 ln of 0.75 t plus 20. Last part, part C, we've still got our cake, but now we're going to decorate it when the temperature has fallen to 25 degrees. The question's asking us to find the difference between when the two models would predict the cake can be decorated. Give me your answer to the nearest minute. So for model 1, that said that theta was equal to minus 3.5 t plus 160, and we want our temperature to be 25. So if we feed that in, now if we take the minus 3.5 to the other side, 3.5 t will equal 160 minus 25. So if you do that takeaway sum, divide by 3.5, that will predict that the cake can be decorated 38.57 minutes later after it's come out of the oven. Now if we have a look at model 2, that said that theta was equal to 140 e to the 0.1 ln of 0.75 t plus 20. So again, we want it to be 25. If we bring that 20 over, it'll be minus 20 and divide by 140. That will then be the e to the 0.1 ln of 0.75t. Now if you do that sum here, that comes out to be 1 over 28, and if we take the ln of 1 over 28, that will equal the 0.1 ln of 0.75t. So ln of 1 over 28, just divide by this term. That gives us that t is equal to 115.8 minutes. So there's a huge difference between the length of time before the temperature is going to be predicted to fall to 25. But all you need to do now is find the difference, which will be the 115.8, take away the 38.57, and that equals 77 minutes to the nearest minute. Thanks so much for watching. I hope you found the content of this video useful and helpful, and your pure revision is going well. Best of luck if you are taking A-levels this summer. Good luck with all your exams. Do check out the channel, like and subscribe. There'll be more videos on there that'll help with your maths revision. So I hope to see you on the next one.